The sun moves in such a predictable way across the sky that you might never suspect that his relationship with Earth is changing all the time. In fact, the average distance between Earth and the sun is not static year over year. So, do we know if Earth is getting closer to or further from the sun, and what forces are acting on our planet and the star to make this happen? In short, the sun is getting farther away from Earth over time. On average, Earth is about 93 million miles from the sun. However, its orbit is not perfectly circular. It's slightly elliptical or oval shaped. This means Earth's distance from the sun can range from about 91.4 million to 94.5 million miles. Still, on average, the expanse between the Earth and the sun is slowly increasing over time. This growing distance has two major causes. One is that the sun is losing mass. The other involves the sun force that causes tide on Earth. The nuclear fusion reaction that powers the sun converts mass to energy, following Einstein's famous equation. Because the sun is constantly producing energy, it also steadily losing mass over the course of sun's remaining lifetime. Estimated at another 5 billion years ago, how stars evolve over time predict the sun will lose about 0.1% of its total mass before it begins to die. Although 0.1% may not should like a lot, this is a lot of mass. It's about the same amount of mass as Jupiter. Jupiter in turn is about 318 times Earth's mass. The strength of an object gravitational pull is proportional to how much mass it was. Because the sun is losing mass, its pull on Earth weakening, leading our planet to drift away from our stars by about 6 cm per year. This is a pretty negligible, especially compared to the normal variation in Earth orbital distance that happens because of its slightly elliptical orbit. Just as the moon's gravitational pull results in tide on Earth, so does Earth's gravity on the sun. Thus stretches the side of the sun that faces Earth, resulting in a tidal bulge. The sun rotates on its axis about once every 27 days. Because this is faster than the 365 or so days it takes so Earth to complete an orbit around the sun. The tidal bulge Earth generates on the sun side head of the Earth. The bulge mass has a gravitational pull associated with it, tugging Earth ahead on its orbit and slinging it further from the sun. A similar effect is leading Earth However, these tidal forces have a very weak effect of Earth orbit. They cause Earth to move about 0.003 cm away from the sun every year. Might Earth's growing distance from the sun influence Earth climate? As the Earth moves away from the sunlight will become dimmer. Given that Earth's distance from the sun may grow 0.2% over the next 5 billion years. This dimming corresponds to 4% reduction of solar energy hitting the Earth's surface. This is relatively small compared to the normal variation in the sun brightness that happen due to the Earth's elliptical orbit, so it's not much to worry about. The bigger thing to worry about is that the sun evolves over the next 5 billion years. Stellar evolution model predict that it will increase in brightness by about 6% every 1 billion years, slowly increasing Earth temperature and boiling of the ocean. This will render the Earth uninhabitable to humans long before the sun over potential swallow it. Recent work suggests the orbit of Jupiter and other planets in the solar system have changed over time. So, could their orbit grow unstable enough to one day influence Earth orbit it closer to or farther from the sun? Or might some other body pass close enough to the solar system to have similar effect? The problem with trying to predict the gravitational interaction of man-body system like the solar system or nearby star is that they are chaotic, meaning they are impossible to predict any certainty. We have no idea where especially the planet will be on time scale longer than around 100 million years, because the tiny error in measurement and perturbation from unmolded interaction grows to a large over time. A 2009 study in the journal Nature that performed about 2,500 simulations of the solar system found that 1% of them, Mercury's orbit became unstable, causing to it crash into either the sun or Venus. So it is theoretically possible for Mercury to move by the Earth and change its orbit substantially, as it did to Mars in one simulation. This is very unlikely though is seen by Rarity in their simulation. It is also very unlikely that a passing star, planet or other body may part of Earth orbit may back off the envelope. Calculation says that we should only expect a star to come closer than the orbit of Pluto about once every trillion years. Any comet already in our solar system won't have enough mass to energy to affect our orbit substantially either. In about 5 billion years after the sun exhausts its hydrogen fuel, it will begin to bloat, becoming a red giant star. Assuming Earth continue uninterrupted on its course, will it have grown far enough away from the dying sun to survive our star's death? There is currently some disagreement about how much the sun will swell during its red giant phase. There is a chance it will not puff out enough to reach Earth, meaning our planet may survive or continue to orbit. However, most estimates suggest the sun will grow enough to swallow Earth, leading to the planet to spiral inward towards oblivion. However, even if the Earth survived, there is no chance that humans would be able to survive with it. The heat and radiation from the encroaching sun would not only boil the ocean and atmosphere, but it would probably boil the Earth itself. Humans would have to leave the flaming lava ball long along its even swallowed. If humans are still around 5 billion years from now and wanted Earth to remain habitable during the sun expansion, we would have to slowly move the planet outward to around the orbit of Saturn, keeping its temperature enough for life as we know it as the sun continue to output more and more energy. This is pretty impractical though. The easiest solution would be just abandon Earth and find another planet or solar system to live in.